Hi, welcome to HashKey Academy. In this Basics of Digital Assets video series, you will learn everything you need to know about crypto and blockchain. My name is Henry, I work as a Senior Research Manager for HashKey Capital, and I will be your blockchain instructor. In this first video, Module 1, Intro to the Blockchain, we will learn all the basics about blockchain. So, without further ado, let's get into it. Hi, welcome to this session on Basics of Digital Assets. In this session, we are going to explore a lot of interesting topics. We are going to look at what is a blockchain and how it works. What are blockchain explorers and how can you use them? The differences between blockchain cryptocurrencies and tokens. What are consensus mechanisms? What is staking? How to store digital assets, and also, very important, the wallet security. All right, I hope you are as excited as I am. I'll see you on the next slide. The Bitcoin blockchain was the very first blockchain ever created. Satoshi Nakamoto launched the Bitcoin white paper back in October 2008, and the Bitcoin network went live on the 4th of January of 2009. Nobody knows who was Satoshi Nakamoto, but he left us a technology that we nowadays use for so many different use cases. But what exactly is a blockchain? The blockchain is a distributed database that is used to record data, can be assets, transactions, anything you want, and it has characteristics such as consensus, provenance, immutability, and finality. The data immutability on the blockchain is achieved by connecting blocks with hash functions and sharing the data with many nodes. It also uses cryptography to sign transactions and data. All right, but what exactly are these things? Cryptography, hashing? Don't worry, join me on the next slide. From a user perspective, you won't really need to understand exactly how the technologies behind blockchain work. Just the same way that when you send an email, you don't need to worry about email encryption, TLS, SSL certificates, TCP/IP, and so on. You just click a button and send an email. The same way when you deal with blockchains, in most cases, you just need to click a button to send a transaction. But what are the technologies that make this possible? Most blockchains work with digital signatures to sign transactions and create the address of the wallet. So we usually have a key pair, a public key and a private key. The public key is going to translate into the address of your wallet, and the private key is going to be what you use to sign a transaction. Most blockchains also use hashing. Hashing is used to create fingerprints that represent transactions and represent blocks of data. And because hashing is very computational efficient, it's possible for computers, miners, validators, nodes, and so on to verify the transaction immutability and integrity very simply by using hashing. Then finally, we have consensus mechanisms that will allow us to have decentralized networks, and it will allow to have all the nodes or miners or validators in a blockchain agreeing on the data and keeping the blockchain on the same page. Until now, we need to trust a centralized party to keep the records of all our transactions, assets, and so on. That's why we nowadays need accountants, notaries, banks, stock exchanges, and so on. But this system has a problem. It has a single point of failure. If you have one single accountant, you need to trust that this accountant is going to do good work because he can commit some mistake or some fraud or cook the books. And how can we solve this issue? Well, imagine for a second that instead of one accountant, that you have 1,000 accountants or even 10,000 accountants working at the same time, keeping all the transactions and all the records of your assets. It will be much harder to commit some kind of fraud or having some kind of mistake if you have thousands of accountants keeping the records of all your transactions, right? This is what a blockchain does. Blockchains multiply the number of accountants in distributed ledger across many of these accountants that we usually call nodes or validators or miners. So, let's recap. In a nutshell, a blockchain is a peer-to-peer network where all the peer nodes, our accountants, will replicate all the data in the ledger. Everyone has a copy of the data and everyone validates and audits the data. There is one more thing I would like to talk about. Have you ever wondered from where does the name blockchain come from? Well, blockchains are chains of blocks, but what does it mean? Well, try to imagine for a minute a paper book where each page refers to the previous page with a specific code. In this case, we call it a hash. The book is the blockchain, and each page in the book is a block on the blockchain. Because each page is numbered with a specific fingerprint that we call hash and refers to the previous page, it's very easy to detect if a page was removed or changed because each fingerprint, each hash, is very specific for that page that contains a number of transactions. Blockchain explorers. Blockchain explorers are basically websites that are a window to the blockchain. They allow any person to use it and search for a transaction, just like a Google of cryptocurrencies and blockchains. They allow any person in the world to search and have access to different details related to transactions, specific wallet addresses, and check, for example, the amount transacted, sources and destination of funds, the status of transactions, and so on. So any transaction that you send on the blockchain, you can see the status of that transaction, the wallet addresses, the amount, and so on a blockchain explorer. Blockchains, cryptocurrencies, and tokens. Many times we use these names interchangeably, but aren't they all the same? Not really. Blockchains refers to the network layer. It is the technology that powers that blockchain network. For example, Bitcoin, Ethereum, and Polygon. On the other hand, a cryptocurrency is the native currency of that specific network. In the Bitcoin case, for example, the cryptocurrency is also called Bitcoin, while on Ethereum it's called Ether, and on Polygon, the cryptocurrency is called Matic. Some of these networks, like the Ethereum network and Polygon, allow the creation of smart contracts, and you can create tokens via smart contracts on the top of these blockchain protocols to represent certain assets. We sometimes call these assets cryptocurrencies, but to be honest, the most accurate word is to call them tokens. And some of the examples of these tokens are, for example, stablecoins that most of the times are created on the top of smart contract blockchains like Ethereum and Polygon. In this table, you can see some examples of what I was just talking in the previous slides. In the first column, you have blockchain. In the second column, the cryptocurrency that corresponds to that blockchain. And third column, examples of tokens that can be created on those blockchain networks. Bitcoin and Dogecoin are first generation blockchains, meaning that they don't have smart contract functionality and you cannot create tokens on the top of the Bitcoin or Dogecoin blockchain. However, on the other hand, the Ethereum blockchain and Solana and many others allow the scripting functionality and the creation of smart contracts. So they allow the creation of new tokens on the top of these blockchains. We have here some examples of tokens such as USDC, the Shiba Inu token, Sandbox for the Ethereum case, or on the Solana blockchain you have the Steppen token, Audios, and many more. Okay, now that we know some examples of blockchain networks and cryptocurrencies, let's talk about consensus mechanisms. A consensus mechanism is the way our accountants make sure that they are all on the same page. In this case, our accountants are the nodes or miners on the blockchain, and the consensus mechanism is a piece of computer program, an algorithm that makes sure that they are all on the same page. And we have some examples that you have probably heard of, such as proof of work and proof of stake. The consensus mechanism solves the Byzantine generals problem. This is a very old problem, and it's basically imagine that you have four generals, four armies that want to attack a city. And back in the day, there was no mobile phones, no electricity, no telegraph, no fax, no email. So, how can they communicate and make sure that they are all on the same page to attack the city at the same time? Now, let's talk about proof of work. Proof of work is a consensus mechanism used by Bitcoin and many other first generation blockchains. It's a leader based consensus mechanism, meaning that for each round, for each block, there is a leader, a miner, that is going to mine that block. To do this, the miners need to calculate a challenging lottery, which we call the nonce, is a number that the miners need to guess in order to mint a new block on the blockchain. Once a node or miner resolves this lottery, it can broadcast the result to other nodes that are going to check the validity, and the new block is appended to the blockchain. This lottery's difficulty is adjusted so that the blocks are produced at the same pace. So in the Bitcoin blockchain, for example, it's going to be 10 minutes, while Ethereum adds new blocks on average every 13 seconds. The proof of work mathematical problem is nothing more than guessing a nonce, a lottery number. It's a long string of numbers with millions or billions of trial and error. That's why proof of work mining consumes so much energy. These miners, these computers need to try millions or billions of times what's the correct nonce, the correct lottery number. A miner must guess this nonce and add it to the hash of the current header, rehash the value, and compare it to the target hash, to what is supposed to be. If it is correct, the miners will receive a reward for their work. By now, you are probably asking yourself, why is proof of work so hard? Well, there is a great reason for it. Proof of work is the way the blockchain is kept secure. Imagine, if it is easy to add a new block into the blockchain, any bad actor could attack the network. I could just create a block saying that I have 100 Bitcoin when I don't have it. So proof of work makes it hard so that there is an incentive to make a good work adding the data into the blockchain. In this chart, you can see how the data is added to the blockchain. In a nutshell, miners will grab the data on the header of the block and they will put it through a hashing algorithm and try announce this lottery number. Then they will compare if the resulting hash is according to the conditions or not. If it is not according to the condition, they will need to try another nonce again and again and again until the resulting hash is according to the condition, and then finally they mine a block and they will broadcast it to the network. Proof of stake is another very popular consensus mechanism. Some of the examples of proof of stake networks are Solana, Cardano, Cosmos, Tezos, Celo, and BitShares. And in proof of stake, the miners are replaced by validators. In proof of stake, the validators will need to stake tokens in order to participate in the consensus. You can see this stake as a bond to behave in the network and to do a good work. If the validators validate blocks correctly, they will receive a reward. But if they misbehave, they may lose part of this stake, of this bond. In proof of stake, the validators will be randomly selected, but the likelihood of being selected will increase the bigger the stake is. You saw before some examples of blockchain networks using proof of stake consensus mechanism, but Ethereum is also moving to proof of stake with one of the upgrades that is going to happen in 2022. In this slide, you can see a high-level diagram on how proof of stake works. Validators are randomly selected, and to validate a block, they'll need to have a stake. On the right, you have some examples of blockchain networks that are already using proof of stake or that plan to use proof of stake in the near future. Digital asset custody. There are different options to store your crypto. In this table, you can see some of these options, but let's start with exchanges and CeFi, centralized finance. These are usually regulated institutions, and you have here some examples such as Binance, Coinbase, KuCoin, FTX, and of course, HashKey Pro. In this case, the private keys of your wallet are kept by the third party, and it requires KYC, know your customer, and identity checks, meaning that you'll have to provide your ID card, proof of address, and so on. In terms of security, it's secure most of the times, and the third party will be responsible for keeping your crypto assets secure. On the second column, you can see crypto custodian services. Custodians are third parties that can be hired to look after your crypto. They usually keep the crypto very secure, and we have some examples such as HashKey Expert. These institutions are specialized in keeping the crypto assets of their customers secure. The private keys that control the wallet are kept by the third party, and sometimes, actually most of the times, they also require personal data and identity checks. It's also very secure, and they are responsible for keeping all your crypto secure. Finally, we have non-custodial options. In non-custodial wallets, you'll keep the custody of your funds and private keys, not with a third party. These are usually, for example, the wallets that you use on your own computer or mobile wallets. Hardware wallets are also considered non-custodial because you keep the custody of your private keys. Let's start with desktop wallets and mobile wallets. Some examples of these wallets are the Exodus wallet, MetaMask, Trust Wallet, and of course, HashKey Me. In these options, you keep the control of the private keys, so you'll have full control over the wallet and no other third party can touch your funds. No personal data is required, and this option is as secure as your computer is. So if you keep your computer very secure, your funds will also be secure. But don't worry, I will show you some security tips on the next slide. Finally, we have cold storage wallets or hardware wallets. This is the best option to keep your crypto very secure and to keep the custody of your private keys so that you have full control over your crypto. Some examples are the Ledger wallet and Trezor. In this case, you will have full control over your funds and private keys, and no other third party can touch your funds, and no personal data is required. This is very secure, but you need to follow some good practices, including doing backup of your wallet. Wallet security. So if you are using one of those non-custodial wallets, you need to keep it really secure. So here you can find some security tips to keep your wallet secure. First, use a strong password for your wallet. It can be the MetaMask wallet, which is the most popular Ethereum wallet, or any other wallet that you use. Please choose a long and alphanumeric password for your wallet. When you do the backup of the wallet, you usually need to handwrite the seed phrase, which is the backup phrase of the wallet. Please don't take a screenshot, don't store it in your computer because your computer may eventually be vulnerable to hackers. Keep it in a piece of paper, or actually 2 pieces of paper, and keep it in 2 different safe locations, just to have some redundancy, just in case. Then, never store your seed phrase on your computer or phone. Again, your phone or computer may be vulnerable to hackers, or it may upload the photo to the cloud and the cloud be hacked, so you never know. You should also store most of your crypto in a cold storage or hardware wallet, like the ones that we saw in the previous slide. You should do annual disaster recovery tests to make sure that you know how to do the backup of the wallet, just in case you need to do it. And finally, buy your hardware wallet only from trusted sources. Don't buy a second-hand wallet. Finally, I have here some good cybersecurity practices for you. I know, this is not the most exciting part of the video. However, better to be safe than sorry, right? First, complacency is the enemy. Make sure that you always double check everything, no matter how much experience you have. The impact of eventually not keeping your crypto assets secure can be huge. And always remember that although most blockchains cannot be hacked, your computer and wallet can be vulnerable to hackers. Let's look at some of these important security practices. First, don't connect to public Wi-Fi networks like in airports, coffee shops, etc. Don't use public computers to have access to your crypto. Keep your operating system updated. Sometimes these updates are security patches. Keep your anti-malware or antivirus updated. Use a VPN. Have a strong password policy and or use a password manager. Always enable, whenever possible, MFA, multi-factor authentication. Never use a USB drive that you are not sure of its origin. And finally, the most important, beware of social engineering. Phishing emails, whaling, vishing, scams. Hackers will do anything to try to trick you to think that they are who they say they are. So always make sure that you are aware of social engineering.